So we are going to talk about today about file formats. It's a very important topic in Radare, okay? So for those that don't know who I am, my name is Alvaro. I've been involved developing Radare for almost 1 year and a half. I came across to this project because I wanted to learn about reverse engineering. And IDA Pro licenses is very expensive to me. And I bought a r2con, but it lacks a lot of features like you can find in Radare, okay? So those are my handles in Twitter and GitHub if you want to talk with me or something, okay? So let's start. So we are talking about file formats. Are file formats important for Radare? The answer is yes, because without understanding the file format, you are going to be able to get, for example, symbols section. Maybe you can start even to analyze it if you they get correctly the entry point. So it's very important. It's going to give you a valuable information when you're doing some reverse engineering of a malware or something, okay? The next question is, are file formats easy to parse? The answer is no, okay? Mainly for two reasons. In a security tool like Radare, we support a lot of file formats with different standards. So basically, you are going to support the common cases, and probably in a CTF or maybe a malformed file, you're going to fail to extract all the information. And secondly, it's about security issues. It's a huge attack surface, and if you don't be very careful when you're coding, you're going to get crashed, or otherwise maybe rep skills is going to report a lot of crashes on GitHub. So it's better to do it right, okay? So for example, to see some tools that fails parsing, okay? Let's go here. Can you see the screen? Okay. So for example, this tool is very known for everyone. And if we try to do this over this file, what do you get? We are gonna get doing that. So if we try, it crashes, okay? And you can see here is because it's trying to allocate a huge buffer. This is a very common case when you try to parse file format. If you don't interpret it correctly and you check against negative values, if the size is greater than the file size, so you're gonna get crashes, okay? Yeah, another example. So LDIT is a tool that is used to get entitlements in match binaries. So it's basically parsing some structures in the file. So if you get that, you're gonna get a segmentation fault. Okay? So it's very common to get this kind of crashes. And if you go directly to the shortcut, it's very easy to spot the issues, okay? So let's see it. So for example, in the first case, in the first class, we have here a macro, xch size, that is directly getting the size from the session header. So basically, if this size is not checked, so maybe is this size greater than the file size? That makes no sense. It's a negative value, also doesn't make any sense. So you have to be careful when allocating a buffer with this size, okay? So if you go directly to the shortcut where it's used, here is using directly the value to allocate memory. So you can directly crash the application, okay? So you have to be very careful. So in the second case that we pass the flag E, you can see here directly we are reading an offset directly from the file. So if that offset you don't check is beyond the buffer, probably you're gonna do reference memory outside of your boundaries, okay? So here we are get the base buffer, we use it at the offset that we read directly, and here we are the referencing, okay? And basically here happens the same issue. So this is very common. I'm not saying that in Radare we don't have this issue, because if you go directly here, you can see a lot of crashes. So we fix this. But the thing about Radar that we normally fix this right away, okay? And you share by Red Skill is very famous here. You can see here all the crashes that we fix it. Okay? So it's a very common thing when you're dealing with security tool to see crashes. So that is very important to have in mind about security issues, okay? So how everything is implemented in Radar. And everything from assembler for analyzing from file formats, we usually use plugins. We have the first plugin is r2con plugin that is meant to be used with flat binaries, one file, one executable. Okay, and the second one plugin is r2con extract plugin that is meant to be used with, for example, fat match, deal share cache, that is files that contain multiple files. Okay, is make things easier to develop that kind of things. And we have two paths in the source code directory. We have learn-bin-p. In this first directory is where you can find all the plugins available in the source code. And in the second path is code that is used by the plugins to start really the information. Okay, so just looking at those places, you basically can start understanding how everything is implemented within Radar. Okay, and in this link, you can check out, for example, how to implement new ones. Okay, but I will see it in real life, how these structures and so on looks like.
¿Estás seguro que está?
Sí, yo creo que sí. ¿No?
Sí.
¿Sí? So the first factors, you can see a lot of callbacks that is going to be used later for Radar to get, for example, sections here, symbols, imports, string. Is a common thing in binaries to get is a very important information. So this is the first thing that you have to create in order to support new file formats. So if we go to this directory, here you can find all the different file formats that we support, as well as the extract plugins over here, deal cache, and fatmac. Okay. So if you go, for example, to ELF, it's a bit tricky to move the. Okay. No, don't worry about it. So if you go to the end, you can see how the binary for ELF is implemented. Okay, we implement all the callbacks to get the symbols, the sections, the relocations, and so on and so forth. And the other directory is companion code used by plugins directly. Basically, normally here is where the magic happens, where directly the code is in charge with dealing with the file. Okay, so normally if you have an issue, you have a crash to fix, you have to go directly here. Okay, so for example, to try to understand everything this, we are gonna make a simple demo that is fixing cough. Actually, cough is an OFI format that is broken in Radar Master. So for example, this is an example. If we try to load this object, it's not because run directory. Okay. You can see we can get the same information, but we are missing some context, okay? For example, you can see here, this calls, but you don't know where it's going, okay? But then you can see it's called message box and exit process. So somehow we are missing symbols and relocations. And we are missing, for example, these relocations for data that should be pointed to this kind of two strings. So it's broken. So we already know where to look. So if we go to the source code, here is the function that is gonna be used to get symbols, because if I saw it, you try to get symbols here, it's broken, you get sections, it's broken, and relocation as well, okay? So even this is implemented somehow, it's broken, and if you spend a little time, the reason is this function, okay? This somehow was commented out because there was maybe a file that was crashing radar at the time, and this is the reason you don't get symbols and sections. So just fixing this, you are gonna get these calls, a call to exit process, call to message box. That's gonna give you more information, okay? And you go here. And for example, relocation is not implemented, okay? So it's very, in Go, the relocation is very simple. Each section header so each section header is gonna give you a pointer to a table of relocations, and it's gonna say you how many relocations it has. Okay, so just using this information, we are gonna be able to get the relocation information. So I'm not gonna do the coding in live. I did a branch. So far, any questions while this compiles? I don't know how it's gonna take. So you can see basically all the plugins for those that went to the squatter talk. We share the same partners, okay? Same structures. It's very easy to deploy or to create new plugins for simply analyzing of file formats, okay? It's taking too long. Sorry for that. So if we are lucky, we get symbols now. Okay, we get the number of sections and relocations, and if you get this assembly is going to give you more information. You already know that the code is going to be a relocation for message box, so you can understand better this assembly. So that is way important to parse correctly the file. So, but we are missing here the relocation. This relocation is not pointing to the string. Okay, so it's still work in progress, but you can see that it's very easy to start parsing or fixing radar, or when you find some new feature that you want to implement, just go directly to this path. Okay. So okay, we are gonna see two examples how to full process. One is because about interpretation of the standard. Another one is dealing with malformed files. The first one is about ELF. ELF is the binary that is used in Linux system to execute the binaries, and it's basically made up from an ELF header, following that from a program header table with a bundled segment is going to be mapped in the memory, and a session header table. And the tricky thing about ELF is that section headers is normally used to assist the engineer when debugging the process to give you valuable information, but it's not used when you run the binary. What is used instead is programs header. So if we don't have that distinction in mind, we can get the wrong output in radar. So for example, the first one, what happens if we have a binary with a section header information? So this is been handled a quite time ago in Radar, but if you try those tools, Hopper, Riddle, Object Down, fails to get symbols and relocation. Okay, so let's see it. So here we try up down to get symbols from an elf that's been stripped, and it said that the file is truncate, okay? And we try read elf. It's saying the same, that it's kind of corrupted, it was not able to get information, okay? But if we try with Radar, you can see here we have more symbols. We can get also the relocation, and this is going to help you again to understand better the program. If you go to main, you're going to see that this code is going to be to put. Otherwise, you will be some code to some direction that you don't know what is going on. Okay, so it's very important. And these tools fails actually. Okay, so next example. This has been fixed the last week, I think, no, Pancake?
Yep.
And was reported in Twitter. So now, for example, what happens if we have section header that says a specific object, you can find a simple print, but in the program header, it says you have the system. So you're gonna get confused, okay? So if we try to load this binary in Radar,
¿Cuál era? No, está aquí. No me acuerdo.
So you can see here a call to system, and if you don't have in mind that thing, it says the print. So for example, to test this, let's go to here. I have a virtual machine. Okay. So what it thinks GDB about this binary? Okay.
So you
can see here a print from Felipe, but Radar was saying it was system, and it is because GDB is reading information from section header, but doesn't take into account the program header. Okay, so if Radar is right, we should hit this breakpoint, and see if GDB is right, we should get hit here. So let's see where it goes, and you can see it go to system. Okay, so it's very easy to confuse these kind of tools with these tricks. Okay, and other example that now is broken in Radar is basically the symbol code is this. If we don't have the session header, get the symbol from program header. Otherwise, get all the symbols from the session header, fix overlap the symbols, and return. Okay. But it's easy to break. But what happened or what will happen if binary says I have one symbol, so you bypass the first checks, okay? But you are missing the symbols in program header. So basically we have to add this, okay? And this is, for example, if we pass the same binary let's compare again master to see what happens actually in Radar. Okay, so here we can see we don't get any symbols, and it's because we said in the section header we have one symbol, so we bypass getting the symbol from program header. So if you have take into account, I'm gonna compile the branch, okay, but I have a fix for this here. Now we can see a letter, okay? So let's continue. So the following example is we're going to talk about PA. PA is the binary that you're going to be using in Windows. And here we have in mind malformed files. Okay, but okay, you normally it's going to support common cases. But what happened is an post-infection from malware changed something from the headers that make your, for example, radar or another tool impossible to map section or change the entry point. So you have to overcome this somehow. Okay. So, and the thing is, okay, this is very important here because sometimes we have to deal with very malformed files, and this sometimes can be lead to breakage. Okay, so we have to take this into account when developing file formats. Basically, the solution is try to detect something that makes no sense. For example, if an entry point to a not mapped section, or it's pointing to a section that's data, or maybe this binary doesn't have any section, but it has an entry point. So you have to try to change this on the fly. To be able to load the application, the binary, to start reading correctly, okay? So for example, let's try, this was the symbol before, so we are now get the symbols with this little fix. But for the example, we are gonna try hopper on a binary. So before to see this in hopper, let's see this binary more closely. So you can see here the headers from the PA. And here what it is, okay, here. The number of sections, it's 0, okay? So that is maybe a condition, very weak condition, but you see here an address of entry point distinct of 0. So it doesn't make many sense. So once you grab the sections and you have the entry point, you have to try to fix this on the fly. So this is the difference in hopper, is what you get loading this file. Because it's not mapping actually nothing because the binary says I don't have any sections at all, okay? And this is what we get when radar. So we're getting code. As you can see here, or you can see, we created a section to try to map the entry point. So that's why we are bypassing the trick from the malformed file to start knowing what it's doing, okay? And it's very simple. This is not very complicated. You go here. So here once we get the sections, we run a function that is pet check sections. It's very simple. So actually, this is gonna do the following. It's gonna check the entry point is always falling in a mapped sections. If the entry point is go beyond file size or is negative, it try to detect a section that has the executable bit active, okay? And with that, we were able to load a lot of malware that before we weren't able to load. So maybe the performance with IDA Pro, we improve it for malware analysis thanks to this simple function. Okay, it's not very complicated, and you can see here, this is the directory that you have to change to support new things. Okay, it's very simple. For those that are interested in malware analysis, This issue is very important. So here you can see a lot of the stuff that we have to support to do malware analysis. And you already know where to start looking. It's very easy. And if you have to be, or you are doing malware analysis, I think that you have to check out this issue. And I encourage you to start coding, adding the features, because it's very easy, it's well organized, everything. And if you spend one day reading the source code, it's very easy to have. So this issue is very important for malware analysis. So yeah, check out. I think that from my side is all. I don't know if anyone has questions about this.